So hello guys, this is a new Leetcode question called minimum cost of conversion of a string. Okay, and it's the first part of it. So let's read the question first. Okay, so here we are given a zero indexed string source and target both of length n and consisting of lowercase English letters. We are also given zero indexed character arrays original and changed an integer array cost, okay, where cost of I is represent the cost of changing the characters original I to changed I. Okay, so you start the string source. In one operation you can pick only x from the string and change it to character y at a cost of z. Okay, if there exists any index j, cost of j is equal to this original of x and changed of j is equal to y. So we need to return the minimum cost of the string source and the string target to any number of operations. If it's impossible to convert the source and target to, so we return -1. Okay. So original of j is equal to original of I. Okay, there may be indices. Okay. So as the question says, uh, we have given uh, array of letters named source. Okay, and source will be like, let's take it A, B, C, and D. I need to convert it into A, C, B, E. Okay, using the original and the tag and a changed array. Okay, factor for the cost, minimum cost. Okay, so here first we will iterate this. Okay, so A. So this is the like if we can say this is the like a graph problem. Okay, we can just say it as a graph problem. Let us say, okay, why I'm saying this, because let's see, suppose we are taking this array original. Okay, so for change, let's make the path for it. Okay, for changing it going from A to B, it takes 2. Okay, then from changing to B to C, it takes cost of 5, and again to B it takes cost of 5. Okay, then from C to E, it takes cost 1, and from and sorry and from D to E it takes cost 20. Okay, so okay, yeah, yeah, so yeah, and from E to B it takes 2 to go back. Okay, let's see, because we are saying the original and cost, we have to convert that original array into the cost changed array. Okay, so cost is this. Yeah, for the now let's we can use this the start and end function. The start will be the original and the end will be changed if we can. Okay, so let's take this example. Okay, here a is a and a both are same, so we will just continue. Then we will compare b and this. They are both not same. Okay, so we'll find the b here. So b is here. Okay, b is here and c is here. Okay, from B to C it takes 5, and we cannot check any other path because 5 on there is only one path going to C, that is 5. Okay, so B to C will be 5. So let's take a cost, that is 0 equal to 0. Okay, and we will increment, we just increment cost, that is 0 plus 5, because B to C, this is not B to C. Okay, that's 5 here. Let's take this plus B to C. Okay, and now let's check C now. Okay, now we did this. Okay, so let's check now this and this, both are different. C to B, for going C to B there are two paths. First going to E, and first we will go to E, then we will go to B, or else from C to B directly 5. What's the minimum? If you are going from C to E, it will be 1, and from E to B, it's 2. So plus 2, which will be 3. Okay, and direct path, that is C to B, is 5. 3, at least almost 3 is smaller. Okay, 3 is smaller, I can say. So here it will be like plus, wait a second, yeah, plus our it will be B, comma C, comma E. Okay, we will add this to a cost now. Okay, so now we'll check for this E. Wait a second, B. Okay, now we will check E and D. Both are different, and there is only one path. That's from D to E. That's 20. Okay, so we will just return 20. So we add plus D to E. We will add this to it, and this will have cost function. That will be like if we say cost is 0, B to C will be our 5, then B to C is 1, sorry, C to E is 1, and E to B is 2, that is 3, plus our DE. DE is D to E is 20. So we'll directly return 5 plus 3 plus 20. Okay, 0 plus 5 plus 20. That is equal to 28. Okay, so we are getting this output 28 here. Okay, so similarly, let's take another example. Uh, Suppose we are given, source is A, B, C, D. Okay, and target is A, B, C, A, B, C, E. We have to convert this. Okay, so and only we can go to from A to E. Okay, so like here we will see DA and A both same. We will just continue. B and B both are same. C and C both are same. Now we are D and E, but we don't know how to go there. So we will return -1 because we don't know how to go. So answer is -1 here. Okay. So like we can just use shortest distance path. Okay. Like we can use Dijkstra algorithm or Floyd Warshell algorithm. Okay. Let's take Floyd's Warshell algorithm here. Okay. Yesterday's question was also the same. Floyd's Warshell algorithm. Okay. So in this, we will just like let's take the original array, like first question our. Okay. What is it? Yeah. Let's make this graph again. It will be like uh, A, B, okay, C, E, C to B, A, and D. Okay, and this will be like this was 2, this was 5, this was 5, this was 1, this was 2, this was 20. Okay, so first we'll create a matrix for this. Okay, we'll create A, B, let's once again, yeah, A, B, C, D, E. Okay, and then we'll again matrix A, B, C, D, E. We get a matrix which first everything will be infinity. Okay, we'll take infinity here everywhere initially because we don't know the distance from any node. Let's do this. Yeah, I'm wasting the time, I know, but yeah, it's good to visualize. It will be easy to visualize. Okay, yeah, that's yeah, I'm done. Yeah, see. Now going from A to B, it will be like two distance. Okay, so it will take. We will remove this infinity, and it will be like 2. Okay, yeah. Okay, then B to C, it will initially A to A was sorry. Initially A to A was 0 because we are at the same node. From going to A to B, it will be like 2. Okay, so we'll write here 2. From A to C, it's impossible, so it will be infinity. C to D, A to D is impossible. A to E is impossible to go. Okay, directly. Then we will check for B to A. It is infinity because we cannot go again back. Okay, from B to B, it will be 0. Okay, it will be 0. Then from B to C, it will be 5. Then b to d it will be 5. Sorry, b to d is infinity. Wait a second. Yeah. Then b to e is infinity. We cannot go back. Then check for c to a. It's infinity. C to b it will be 5 because it's given there. Okay, it will be 5. Then from c to c it will be 0. Okay, so we can just write like everything as 0. Okay, the column and row. Okay. 0 and 0 because it will be same everything every time because we cannot self traverse. C to D is not possible. C to E is 1. Okay, so it will be like infinity and 1. Then D to A is not possible, D to B is not possible, D to C is not possible, D to E, D to D is 0, D to E is 20. Okay, so it will be 20 here. We can just go to B with a cost of 2. So we have initially created this matrix. Okay, so in Floyd Warshell algorithm, what we do is we will first check this element. Will the path from going through this element will decrease the cost or distance of the path, or it will be the same. Okay, if it decreases the path, we will check that path, or if it is more than the original path, we will just ignore it, or else if it is less than the original path, we will take this. Okay, so now a to a 0, a to b also of course 0. Then going from A to C. Okay, it's not the mid element, like going through this. Okay, so it should be a mid element. A is not a mid element here. Okay, so A will not change. From B to A, we cannot go. Then B to B, it will be 0. And B to C, yeah. B to C, it will be like 0. It's the same because we cannot change it. B to D will also be same. B to E also the same. Okay, now we will check the C. Okay, C. C to A is not possible. C to B. Okay, C to B, there is possible. There is path 5. Okay, so C, E, B. So it can become like if you are going through this path, this is the minimum going through C. Okay, and it's the mid element. So we can just say we will take it 1. We will take this 1 and 2. Okay, so it will be like now we will just remove this and make it 3. And C to C will be 0, C to D, C to E is 1. Okay, and same with other thing. Okay, it will not change that much. Everything will be same here. Okay, so we got the minimum matrix, minimum cost function here. Okay, minimum cost matrix here. So now if we want from A to B, we can just take 2 here. We want B to C, we can just take 5 here. B to B, C to B, can take just 3 here. D to E, we can just take 20 here. Like that, we can just take this. Okay, so yeah, let's see the code now for Floyd's Warshall algorithm. So guys, this is the code. Let's remove this and start from scratch. Okay, yeah. So first we will create edges of the graph. Okay, so it will be like a list of zip. We will zip like merge all the things. Source, source, target, and our cost. Okay, it will have created the weighted graph of the path of the graph. Okay, so now we will create a matrix. Suppose let's take it min cost. Min cost is equal to it will be like float infinity because we need infinity star our suppose yeah there is only 26 alphabets in English letter that is constant, so we can just take 26 here. Okay, we can just multiply 26 here because we know that the length of English words are same, that is 26. We have only 26 letters, small letters. Okay, as mentioned, it is only small letters given. Okay, lowercase I should say. And for we'll create a 2D matrix for in range 26. Okay, and now we will like we know that we cannot self traverse it, so the diagonal elements will be 0. Okay, so we will create like for I in range our 26 because we are doing 26 or 26 matrix. So uh, min cost of I that the same element will be 0. Okay. And now, suppose if you are not see the yesterday's Floyd's algorithm question, you can just click the I button here. Okay. So just click it, you get the link. I have attached the link here. Okay. So let's write the Floyd's algorithm. Okay. So let's okay. For k in range, for k in range 26. Okay, and for I, k is the middle element, like from which we are traversing, and I is the first element. Okay, range 26 for j in range 26. Okay, j is the last column element. Okay, row, column, and the middle element of it. That's k. Okay, so we are taking if our min cost of I and k is not equal is equal to equal is equal to our, sorry, my bad, is not equal to our float infinity. Okay, float infinity, or our column and the element which you are comparing. Okay. Okay, min cost our j comma k is not equal to our infinity. Okay, we will just get the minimum element. Okay, minimum cost for the element I and j will be uh yeah, I and j will be our minimum of min cost I and j, or we can say, okay, let's take this, and or min cost of ik, and plus our min cost of kj. Okay, we can just write this. Okay, so now we have created the, this is the code for Floyd's Warshell algorithm. Okay, so now we need to add all the elements, like initially we have to like map everything, like where we can go from which element. Okay, so for our, let's take our source. So wait a minute, I have by mistake take, it should be original here. Okay, original, then our changed, because we are changing to that element, it's the edge. Okay, this is the original, and the change are the elements, and cost will be the weighted path. Okay, I mistake about that. So let's take a variable orig, that will get the original, comma our uh, let's change element, and our cost path, let's take a cst in edges. Okay, so our start will be our because the a is a character. Okay, we need to convert it into numbers. So Python has a function called ord. Okay, that will be like org ord minus, we are decreasing the ASCII value from it. Okay, ord a, and end is equal to our ord, our changed element, minus ord our a. Okay, we are removing the ASI value. Okay, so now minimum cost will be our start, the start element and end element number. Okay, equal to our cost minimum, that's minimum of cost, or our min cost. So we can say that min cost start and end. Okay, if we are getting something different, okay, in future we can just write that with that. Okay, minimum of that. Okay, yeah, we have done the algorithm. Now, so we'll create a variable called cost is equal to 0, initialize it with 0, which will return the cost of it, like the value of the path. Okay, from traversing to original to changed. Okay, so we will create a for loop which will like source and target in zip, because we have to merge both the things, because just to reduce the loop. Okay, our source and our comma and our target. Okay, source and our target. So now we will iterate it. If our source uh, if our source and is equal to our target. Okay, source equal to target, we will just continue. Okay, we will not take this. And if it's not, we will just add the it to the cost. Okay, cost plus is equal to uh, cost plus is equal to min cost. Okay, so we have to create now start is equal to ord our source. Okay, because we need to convert it into a number, so it will be like this. And end is equal to ord our. Okay, let's take this as tar. Okay, it will be easy. Tar minus ord a. Okay, and we will make it tar. Okay, so here it will be start and our target. Okay, start on our end here. Okay, plus this, we'll add this. And okay, we are done. And now here we will return cost. Let's check this. Okay, so here we are getting the error minimum listing is out of range. Why it's getting minimum cost? Okay, my bad. I have initialized it in a wrong way. This is a smaller list. Okay, let's check this now. Okay, in long type. Let's check it again. So here we have missed something. We didn't handle the infinity condition. Okay, so it will be like minimum cost of our source and target is if our it's if it's infinity. So okay, float our infinity. We will just return -1 because uh, we cannot return something like if we see it in this condition. Okay, here because D and E is different and we are not given the path for it, so we will return -1 here. Okay, so now let's check it. Okay, return -1. Okay, let's see. Okay, yeah. Okay, now it should work. It's always a good thing to check it before submitting it. Let's check this. Yeah. Okay. I think this is one of the most efficient solution, and don't believe in this Leetcode graph because it depends on their machine also and our runtime also. Okay, so yeah, it's I think it's one of the most optimized thing. 26 to 3 because it's a constant. Now we can just say it's a constant. So O of 1. Thank you. If you have any better approach other than Dijkstra algorithm, please comment down.